Welcome to all of you. Now we discuss about Newton-Raphson method, practical problem number 5, paper CC 14, C programming semester 6, CBCS. This is the Newton-Raphson method for simple real root. Problem 5, write a C program to find the least positive root of the following nonlinear equation using Newton-Raphson method correct to 6 decimal places. X to the power 2 tan x minus e to the power 1 plus r by 20 sin x minus 3 equal to 0, where r is the last digit of your CU roll number. This is the C programming, has included stdio.io.h, has included con.io.h, has included math.h. First we define the function fx. This is the float type function. So float f and arguments are float x and integer r. Float s, the return value s is the power x comma 2 into tan x minus exponential 1 plus r by 20 into sin x minus 3. Return s. Next we define derivative of fx and we call it f dx. This is also float type function. So fd, float fd, and the arguments are float x and integer r. And this is the s equal to 2x into tan x plus x power x comma 2 into power sec x. So we define 1 by cos x, sec square x, derivative of tan x. So power 1 by cos x comma 2 plus e to the power 1 plus r by 20 into sin x into 1 plus r by 20 into cos x, and the return s. And this is the main program and the integer main. Here x, h and error are the float type variables, and here the defined error that is equal to 0.00000001, that is 0.601, that is 1.0 and e to the power 10 to the power minus 7. Integer r is the integer type variable. First we printf, enter the value of r, scan, and you input this value of r, the last digit of your roll number. And next, n is the integer type variable. This is the step counter. N is the step counter. Initially n equal to 0. Here the calculation colon, if this derivative is small, then we again repeat this calculation and come back to this stage. Printf entered an initial value of the root. Scanf ampersand percentage f ampersand x. Obviously x must be in the domain of the function fx. If absolute value of f dx comma r is less than this error term, then print f error, the derivative is too small to implement Newton-Raphson method. So we change the initial value of the root and go to the calculation step here. Else printf, this is the straight line, this for decoration of this problem, and printf this x, h, x plus h. H is the minus f by f dash, this f dx. While absolute value of h greater than the error term, then printf this percentage d, percentage a, percentage a, percentage f. So first the n is the step counter, number of steps, x the approximation of the root, and h that is the minus fx by f dash x, and this the corrected value x plus h. And then this new x equal to the x plus h, and calculate h, this equal to minus f by f dash, an increment of the step counter in plus plus, and print f. The required root is percentage 8.6, this x, because you want to the root up to 6 decimal places. So total place is 8 and 0.6 is the decimal place up to 6 decimal place, return 0. And first we uh, save this problem, and next compile, and there is no error, and then F10 is run of this problem. Enter the value of R. We put here 9, last digit of your roll number, and enter an initial value of the root, say 1. So this is the table, this step here up to 9, 10th step, this a value of x, value of h, and x plus h, and the value of x this 1.327130, 1.327124, 1 point at the 8th step 1.327125, the 9th step is 1.327124. So the between two values of x is modulus of this value xn and xn plus 1 is less than the error term. So the required root up to 6 decimal places, correct to 6 decimal places, 1.327124. Now we plot here the function fx is x square tan x minus exponential 1 plus r by 20 sin x minus 3. Here the r equal to 9 put here. So this is the function, this red color, this is the x-axis, this is the y-axis, and this point is value of the root where the function cuts the least positive, that is the smallest positive root. So this is the smallest positive root, and this intersection also, there are so many intersections of this, so these are also roots, but the smallest positive root of this function is the 1.327, and also for r equal to 9 also we get 1.327 from the C programming, and from the Desmos app we also get the smallest positive root is 1.327 here. And actually the Newton-Raphson method here, this graphical representation of this Newton-Raphson method, this is the x-axis, the y-axis, and this is the function y equal to fx, and this is the initial approximation x0. So first we draw the vertical line up to cut at this point x0 x0, and draw a tangent. This is the f dash x, and this is the where this tangent cuts the x-axis, this x1, the first approximation to the root. And again we draw at the point x1, vertical point x1, we draw a tangent on this curve, and this tangent also again cuts the x-axis at the point x2, and this is the second approximation of the root. Actual root is this, this where the function fx cuts the x-axis. This is the root, actual root alpha, and this is the approximate root x2. Now we this program select all, and then copy and paste on a Word file. This is the Word file, this is the page number on the right hand side, this is the date, the heading, Newton-Raphson method for simple root, the description of the problem, and this is the roll number, registration number, and this is the problem, C programming, and the output, and output is this, we put here output is this, copy this table and paste in this Word file, and this is the output, and the required root is this. And thank you for watching this video.